Hello out there, welcome to this tutorial on binary operations. If you are joining us now, check the description section of this video on our YouTube channel to get the link to the playlist containing all the videos on binary operations. In this video, we'll be looking at some miscellaneous problems. We start with problem 1. The operation dot is defined on the set R of all real numbers by x dot y is equal to 3x plus 3y all over 3 plus 2 for all xy in R. A. Evaluate 1, 2, operation negative 3, 2, 2 over 5, operation 3 over 5, and 3, 3a, operation 5a. And for B, we have if m, operation 3 is equal to negative 4, find the value of m. Before we start, we'll look at the operation. Is it possible we simplify it? If you look at it, split it into individual fraction, we know that x operation y will be 3x over 3, which is x, 3y over 3, which is plus y, then plus 2. So I have simplified the operation to give me x plus y plus 2. So we now start with A. For A, I have the first question there, 2 operation negative 3, which means x is equal to 2 while y is equal to negative 3. So we now substitute into this operation. So we now have it as 2 plus negative 3 plus 2. So collecting the positive terms, 2 plus 2 gives 4, 4 plus negative 3 gives 1. And therefore 2 operation negative 3, according to this definition of operation, is 1. Then we go to A2. For A2, 2 over 5 operation 3 over 5 means x is equal to 2 over 5 while y is equal to 3 over 5. So substituting into this, we have 2 over 5 plus 3 over 5 plus 2. 2 over 5 plus 3 over 5 is 1. So plus this 2 gives 3. Then we are done with that. We go to problem A3. For A3, we have 3a operation 5a, which means the whole of this is x while the whole of this is y. So substituting again, I have 3a plus 5a plus 2. 3a plus 5a gives 8a, then plus 2. So we cannot simplify further. We leave it like that. Then we go to the B part. For the B part of the problem, if m operation 3 is equal to negative 4, we have to find the value of m. So we know m operation 3 is equal to negative 4. So at this point, we look at the definition of m operation 3. So m operation 3 is m plus 3 then plus 2 is equal to negative 4. So where m will be negative 4 minus 5. 3 plus 2 gives 5. So the 5 going to the right hand side becomes negative 5. So where m is equal to negative 9. And that is all for the solution of problem 1. When we then go to problem 2. For problem 2, the operation diamond is defined on the set Q of rational numbers by x operation y is equal to xy over 3 for all xy in Q. A. Show that the operation diamond is both commutative and associative. B. Find the identity element in Q under the operation diamond. And C. Find the inverse of x in Q and state whether or not every element in Q has inverse under the operation diamond. So we start with the A part of the problem. So now we show commutativity. For commutativity, what we need to show is x operation y equal to y operation x? So since we have already gotten x operation y, we'll now look for y operation x. By this definition, the first element is y and the second element is x. So which means it is going to be interchanged here. So we now have it as yx over 3. We have already established in our previous video that multiplication of rational numbers is commutative. So yx will still be xy over 3. And this xy over 3 is x operation y. So we have shown that y operation x is equal to x operation y. Then we conclude commutativity shown. We go for associativity. For associativity, we need 3 elements to show associative property. So x, y, z in Q. Then we now show is x operation y in bracket operation z equal to x operation open bracket y operation z. So we start from the left hand side, which is x operation y in bracket operation z. So we pick these first two. We know x operation y is already given to be what? xy over 3, then operation z. This operation this, now if you take this as one element, which means it's going to be xy over 3 times z over 3. So we now have it as going to be xyz over 9. So we leave this as left hand side. For the right hand side, which is x operation open bracket y operation z close bracket, we have it as x operation y operation z is going to be yz over 3. And invariably, this is one element, this is the other element. We are still going to have it as xyz over 9, since it is this times this divided by 3. From here, we can see that the left hand side is equal to the right hand side. Therefore, associativity shown. Then we go to the B part of the problem. For B part of the problem, find the identity element of Q under the operation diamond. Now we let E in Q be the identity element, and with that, if x is in Q, then x operation E is equal to x. This is by definition of identity element. So by this operation, it is going to be xe over 3 is equal to x. If we cross multiply, we have xe is equal to 3x. Dividing both sides by x, e is equal to 3. So having gotten e to be 3, we say the identity element in Q is 3. So we are done with that. Then we go for the inverse of x. So we go to C part of the problem. For C, find the inverse of x in Q and state whether or not every element in Q has inverse under the operation diamond. So we let x raised to power minus 1 in Q be the inverse of x. Then x operation x inverse is equal to e. And remember, we have calculated our e to be 3. So, and by the definition of this operation, we have it as x inverse over 3 is equal to 3. If we cross multiply, we have x inverse is equal to 9. Then we now divide both sides by x, because we want to make x raised to power negative 1 as the subject of the relation. So dividing both sides by x, we have x inverse to be equal to 9 over x. So you can see now that the inverse of x is 9 over x. The question went further to say we should state whether or not every element in Q has inverse under the operation. So we can see now that if x is equal to 0, the inverse of 0 at that point does not exist, since it is not possible for you to divide 9 by 0. So it is undefined. So we now say the inverse of x is 9 over x, and x is equal to 0 has no inverse in Q. So with this, we are done with problem 2. We then go to problem 3. For problem 3, the operation delta defined on the set M, which contains elements w, x, y, and z by the table below. A is M closed under the operation delta. B is the operation delta commutative in M. C, what is the identity element if it exists? D, show that the operation delta is associative in M. So we have 1, 2, 3, 4. With this, we start with A. The question is M closed under the operation delta? Yes, since W operation X gives X, then also X operation Y gives Z, and finally Z operation X gives W. We conclude that M is closed under the binary operation delta. So we go to B. For B, is the operation delta commutative in M? So to show the commutative property in M under the operation delta, we pick any two elements. So let's pick W and X. So since W operation X is equal to X, W operation X is equal to X. And if you look at X operation W, X operation W is also X. So we now say this is equal to X operation W. Then the operation delta is commutative in M. So we go to C part of the problem. For C, what is the identity element if it exists? So to do that, we want to check which element, when operated with another element, will still give the other element. So we start with W. Operation W gives W. W operation X gives X. W operation Y gives Y. And W operation Z gives Z. We now demonstrate it here. So we say since W operation X gives X, W operation Y gives Y, you have just seen it, W operation Z gives Z. Even the W operation itself gives itself. So we now conclude the identity element is W. And we've just finished solving problem 3C. We go to 3D. Problem 3D, we are to show that the operation delta is associative in M. So to show that, we need 3 elements. So we are picking the first 3 elements. Then the question is W operation X in bracket operation Y equal to W operation open bracket X operation Y? So we start from the left hand side, which is W operation X in bracket operation Y. What is W operation X? It gives X, then operation Y. X operation Y, X operation Y is equal to Z. So we have gotten the left hand side. Then the right hand side, W operation open bracket X operation Y. So we have W, X operation Y is x operation y is going to give us a z. So w operation z will then give us a z. So we can see now that the left hand side is equal to the right hand side. Then we write w operation x in bracket operation y is equal to w operation open bracket x operation y, then close the bracket. Then we now conclude the operation delta is associative in M, and we have done justice to problem 3. This is where we are going to end the tutorial. I hope you enjoyed it. Check the description section of this video on our YouTube channel to get the link to the playlist containing all the videos on binary operation. Remember to subscribe to our YouTube channel. Until we join you again, goodbye.